So in this little video here, what I'm attempting to do is answer the question that I've been asking: is this saltwater weight loss thing a real thing? And so I decided to try getting some capillary glass tubes, just because I want to test the interaction between the salt water and the glass, and as an effect over time to see if indeed it is actually losing weight. And so what I want to show in this video is so far, after doing many experiments which I haven't shown publicly, but this one here I believe at this point is the most pronounced effect. And finally, I just wanted to show how I stumbled across this effect, which is not related to magnets at all, which came as a surprise to me. Now let's roll the intro. So this is the experiment with the capillary tubes. As you can see, they're in this sealed pop bottle with a little bit of salt water at the bottom. The data and the chart strongly suggest a drop in weight not associated with evaporation. This is another series of experiments I was doing on the mechanical triple beam balance, which showed a change in weight over time. The changes in this case are small but noticeable if you're looking for them. It's simply a small stack of glass plates with some salt water that's wicked up between them. So in trying to set up a control jar to weigh against the jar that I was applying a magnetic field to, what I found was that the control one actually changed more. As you can see on the chart there, that would be the blue bars, and the control jar is the jar with the red sticker on it. And of course the red bars indicate the clear jar that had the magnetic field applied to it. Note the difference. The last set of bars on there represent weighing after about 400 minutes. The next series of experiments I show here is actually very interesting. So what it is a comparison between basically jars with the caps off versus jars with the caps on, and then there's a comparison between jars with just tap water and jars with salt water. And so I take a number of measurements over time And this is the data that I get and the graph of that data. What I really wanted to find out was how evaporation is a component of this, or if it's not, if it's independent of evaporation. So if you look at the chart there, you'll see the two lines at the top. The yellow and the blue lines represent the jars with the caps off, so they were allowed to evaporate. So that's a jar with salt water and a jar with tap water. Now compare that to the lines with the caps on, the red and the green representing the salt water. So what seems obvious is that the jar with the salt water and the cap on had the greatest weight loss over time. So it appears that evaporation is not the cause of what I'm observing here. And I should mention the caps have like a wax paper membrane underneath, and I squeeze them on very tightly. And so I did the freshwater comparison first, and then I did the saltwater comparison after, with the lid on, lid off. So in answering the question first, why is this happening, or what might be going on, I want to be very careful about that. But I think I can offer a few preliminary ideas or thoughts on what might be happening. As you can see in these two diagrams here, you see the water molecules surrounding the chlorine and the sodium ions on the left. And as most of us know from high school chemistry, water is a very polar molecule, and you'll see in that diagram there, the green balls represent oxygen and the red balls represent hydrogen. And so the green balls will be attracted to the red balls, which are the positive charges. So we might imagine then that the two sets of water molecules there will be attracted to each other, bringing the sodium and the chlorine together. And if you look over on the right diagram there, you'll see a very simple illustration showing that water molecules have different modes of rotation and vibration and that sort of thing. So what I think might be happening is, as is well known, water sticks to glass because of the electric attraction, which is called molecular adhesion. So glass is believed to be somewhat negatively charged, which means it's going to attract the positive protons toward itself, aligning the water molecules normal to the surface of the glass, restraining motion to primarily rotational type, the rotational type of motion. And because protons are relatively heavy masses on the subatomic level, you have these protons rotating around an axis, then what we have is a gravitomagnetic polarization. And this gravitomagnetic field might propagate very well through water, just like a magnetic field propagates very well through iron because of all of the electron spins and the spin density. It makes it very permeable, so water might be very permeable to gravitomagnetic fields. And in the comparison or analogy with Maxwell's equations for electromagnetism being applied to gravity fields, what we see then is a situation where a changing gravitomagnetic field will cause a changing gravitational field in tandem with it. And given that sodium and chlorine both have nuclear spin, it's possible their nuclei could be aligning to some degree with this internal gravitomagnetic field. The other idea I had is that the polarization, which happens as a result of the water molecules sticking to the glass and aligning themselves together to some degree, is that there would be a decrease in entropy of the molecular motion and spins and quantum spins and that kind of thing, reducing the degrees of freedom of the particles, and so less internal energy or less internal momentum could result in a decrease in mass, as energy and mass are supposed to be equivalent. But aside from all these ideas, I think the important thing is to be able to demonstrate and show that this type of thing is actually physically possible, that something can change its mass by changes in its internal energy states or by being stimulated with electromagnetic energy or by other means. I think this is a very important thing, that we understand that it is possible. And that is the first step forward, and let the theorists and those who are better at that type of thing
figure all that stuff out, and I welcome that in the comments as well. And please consider subscribing and hit the notification bell to stay updated on future releases. Thank you for your support.
Fail Forward Research signing out.